Alright, so hi guys. So I hope everybody is having happy holidays to everybody. With your family and all that good stuff. So I wanted to make this video over how to find the integral of tangent of x dx. Now, I don't think I've ever gone over this kind of problem, but I have always wondered how because usually they would give it to you in calculus, just as for you to save time with certain integrals that you have to find, where you have to actually find the integral of tan x that involve finding the integral of tan x. However, I wanted to go ahead and show y'all how to find the integral of this. It really doesn't matter, because there's two ways to write it, but it doesn't matter how you do it. I'm going to show y'all both ways, but or both answers to this, but either one is fine. So remember that for this kind of problem, we want to remember that from trigonometric identities, that tangent of x is really equal to sine of x over cosine of x. So here we're gonna just rewrite this as sine of x over cosine of x. So that is the first step here. So I'm going to say that this is equal to the integral of tangent of x dx is actually going to be the integral of sine of x over cosine of x dx. Now here we want to go ahead and do some u substitution. In this case, you can try to do the see what works best, but here I do think that making u equal to cosine is the better option. Now, whenever we do u substitution, we always want to find du. So from trigonometric derivatives, we should know that the derivative of u with respect to x is negative sine of x dx. Here, we're going to go ahead and just try to get dx on its own. So as of right now, what I'm going to do is, for this part here, I'm going to rewrite it given what I put in for u, and then for, just kind of putting in u right there. So in this case, I made u equal to cosine, so I'm just going to say that this is equal to the integral of sine of x over u, and then I'll just put dx on its own like that. And however, we want to make sure that we make integral in terms of u. So I'll write integral in terms of u. That is always our goal when it comes to u substitution. So that is kind of, this right here is our goal, right? So then to solve for dx here, I'm just going to go ahead and divide both sides by negative sine of x. I can say that dx is actually equal to negative du over sine of x. If we let this be true for the dx here, we're going to go ahead and have the following. This is going to equal to the integral of sine of x over u, and then we're going to put times negative du over sine of x. Now, there is one thing that does happen, and that is that the sine of x will cancel out. So then we're going to go ahead and do the integral of negative 1 over u du. Remember that the derivative of natural log of x is really going to be 1 over x dx. not dx, if we actually multiply both sides by -1, right? We can say that the derivative of negative natural log of x is really -1 over x. That's why. So using this information, I can let and because the derivative of negative natural log of x is -1 over x, we can say that the integral of -1 over u du is really negative natural log of, and I'm going to say the absolute value of u in this case, because usually when we talk about the integral, we always put an absolute value. It just depends on the problem, unless you're doing, it just depends. But in this case here, we're going to go ahead and just put a plus c here. And so then from this, we're going to end up having that the integral, therefore, of tangent of x dx, and because I know that I went ahead and made u equal to cosine of x. So again, I want to make sure and reiterate the fact that u was originally cosine of x. So therefore, I know that really the integral of tangent of x dx was really going to be, it's going to be negative natural log of the absolute value of cosine of x. Now, there was, and then plus constant of integration, c. Or you can also say, if you want, I don't know if they allow this, but negative natural log of cosine of x, just like this, plus constant of integration, c. There was another answer. So there's a second answer to this. It involves having to use trigonometric identities and also laws of exponents. If you using laws of logarithms, excuse me, or properties of logarithms. So if they do want it that way, and if let's say you're doing a study guide and the answer key has this second answer for this one, and you want to make sure, I want to make sure y'all understand how to do it this way. So remember that from properties of logarithms, the natural log, or ln, of b to the a is really a natural log of b, or ln of b, really. And so here, we're going to go ahead and use this to rewrite negative natural log of cosine of x in terms of actually we're going to go backwards. So right now it is of this form, if you think about it, because we have -1 natural log of cosine of x. However, we're going to rewrite it so that it is in terms of secant, and I will explain why. So if I move this -1 to the front here, I'm going to try to use that power property. So I'm going to say that this is the natural log of, and what I'm going to do, I'm going to put actually some brackets, and I'm going to say that this is cosine of x, and it's actually going to be raised to the -1 power. Because again, we're moving that -1 to the to that exponent there, to the as an exponent using power properties. So then we know that anything raised, so if I know that so another thing is that u raised to the -n, I know that, again, from properties of exponents, this is 1 over u to the n. Okay? And so then here, we're going to just go ahead and use that. So then I know that this is going to be natural log of the following. It's going to be 1 over cosine of x. And obviously, I know that we raise it to the first power. However, we don't really, since it's to the first power, we don't really have to do anything with that. So in other words, this is going to equal to natural log of the quantity 1 over cosine. Over cosine of x. Now, this last step, guys, does have to do with actually doing trigonometric identities. So remember that from trigonometric identities, and I don't know if I wrote this down already. I think I did. I don't know if I did that already. Okay, no, I didn't. So, from trigonometric identities, remember that 1 over cosine of x, this is the reciprocal identity, is really equal to secant of x. Okay, so we're going to rewrite this here as the natural log of secant of x. And so here we end up having that the integral of tangent of x is really going to be either the natural log of secant of x. So thus the integral of tangent of x dx is equal to, number 1, the natural log of secant of x, the natural log, and I'm going to say the absolute value of secant of x, plus the constant of integration c, or 2, the natural log of or in other words, or negative natural log of cosine of x, I think is what it was, right? Yeah. Or negative natural log of the absolute value of cosine of x, plus a constant of integration c. So these are the two answers, guys. I know that this is a lengthy video, and I do apologize, but I was very stumped when I was doing an integral problem involving tangent of x. Here is how we go ahead and do this. This is how we do this problem. And so if anybody does have questions over this, please let me know. And I am going to also use this integral to do another problem that was a lot harder that I did have a lot of trouble with. But I will go over that in the next video. So with that being said, guys, thank you so much for watching, and I hope everyone has a happy holiday. And with that being said, please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.